So, Kaylee, I'd like you to give Patsy a read for me.
F of x is equal to x squared minus 2x minus 15. Sketch a graph, roots, y-intercept.
All right. So we're gonna factorize this thing, right? So, Kaylee, what is the coefficient of x squared? Simply the number in front of x squared. What's the number in front of x squared? Do you know?
1.
It's one, right? So we call this a simple trinomial. We call it simple because it's just one, and trinomial because it have three terms. You see in that one, two, three. And this is the easiest one to factorize. So, Kaylee, to figure out the roots, I'm going to factorize and I'm going to put this entire thing equal to what? If I want to figure out the roots,
You're
remind
gonna,
me. Yeah, continue.
you're gonna put the entire thing equal to 0.
Right. And that is because at the roots, what is equal to zero? Remind me. At the roots, what is equal to zero?
Is it the
Remember, roots is just a fancy word for x-intercept. So at the x-intercept, what you know? What
that
is
it is equal to 0?
what is equal to zero at the x-intercept? The x value or the y value?
The y value?
Yeah. And
Yeah.
no, where's f of x? Where's another way I could write f of x as what?
1?
Now y. Remember, f of x is y.
Y.
And you're saying
Yeah,
that
y.
y is zero. So that's why you put in the entire thing equal to zero.
To 0. Right.
Right. Let's factorize this thing now. So x squared is just simply x by x. And then you're going to look at the last term. The last term here is minus 15. And so, Kaylee, I want you to think of two numbers that would multiply to give minus 15, right? Multiply to give minus 15 and add to give minus 2, which is the term in the middle. So can you think of two numbers?
So will it be negative 5 times 3?
Negative 5 times 3. Let me see. So, Christian, do you know that negative 5 by 3 is negative 15 or nah? I don't know if you know that,
Yes, sir. I know that.
right? Because a negative by a positive is a negative, and 5 by 3 is 15. Hence, the negative 15.
Yes, sir.
And
Yes, sir.
when you're looking at this one, I want you to think of it as, okay, I owe in somebody $5 and I get them back $3. How much is still owing them?
$2, sir.
So negative 2, right? So excellent job, Kelly. These are the two numbers you were supposed to pick, minus 5 and 3. Minus 5 and 3. Now, Kelly, remember this was equal to 0. And so from here, we are trying to figure out the values of x that's going to make each bracket 0. So, Kelly, what value for x would make that bracket 0? Just by looking at it. What value for x could make that bracket 0?
0?
Now, if you put x as 0, 0 minus 5 is minus 5. That's not 0. What minus 5 is 0? I feel like you're overthinking it. What minus 5 is 0?
5, sir.
Yeah, Kelly, 5. Kelly, what's 5 minus 5?
0, sir.
Yeah, it's 0. And Kelly, what value of x would make this bracket 0? So, Kelly,
3? No.
what's
Oh,
the opposite of plus 3?
minus 3.
Right. Minus 3 plus 3 is 0. Kelly, be honest with me, right? You know why we just do that? You know why we just even bother with that doing that? Oh, no.
Is it in order to like see where the I want to say where the, like the y-intercept is?
Nah, we dealing with the x-intercept here. This is the roots slash x-intercept.
Oh, well, we find in the roots.
Okay, so Kelly, this 0 here is really what f of x is. Remember, we say in f of x is 0 because that's the y value. and at the x-intercept, the y value is 0. So, Killy, if I have x minus 5 in brackets and x plus 3 in brackets, and we are supposed to get 0, remind me, Killy, what is 0 by anything? What is 0 by anything? 0.
0.
Right. So if I could make this bracket 0 somehow, then 0 by the other bracket would give me what for sure?
0.
Yeah. And what value of x would make this bracket 0?
Um,
So we could replace x with and put instead, so that minus 5 will give you 0. What minus 5 is 0?
5.
Right.
5.
So when x is 5, you're going to end up with 5 minus 5, and that's going to make this bracket turn to what? A whole bracket.
0.
Right. And 0 multiplied by the other bracket is just?
0.
Right. So, Kelly, that is the whole concept. You are trying to figure out what values of x is going to make the linear factors equal to 0. By the way, these are linear factors, the x minus 5 and the x plus 3. So I'll put this is the long working, right? I'd put x minus 5 is equal to 0. And Keely, I would then solve for x. So to solve for x here, what would I do? Tell me, Keely, what would I do? To solve for x here,
You,
like the long way. You have negative 5 on the left-hand side. So where would you, what would you do to get the find for x?
you would take the -5 and carry it to the other side.
Right, and that would turn to,
0 and well, turn to +5.
and that would just be 5, right? 0 plus 5 is 5.
Yeah, 5, yeah.
And Keely, that makes sense because when, Keely, when you look at this, right, you are trying to figure out the value for x that's going to make that entire thing equal to 0. What value for x is going to make that entire thing equal to 0? Just by looking at it. Forget about the fancy math,
5.
just look at it. Yeah, just 5, right? So you can see it with your
Mm-hmm.
own eyes. Then we have x plus 3. Guys, do we even need to do the algebra, or could you all see it? People in class, I mean, if all you've seen it, what value of x is going to make that left-hand side 0? Are you all seen it?
Yes, sir.
Wait, it is.
-3.
Right. And if you take the plus 3 and you move it across, it would turn to -3. So excellent job, guys. We just figured out the roots or the x-intercept. Okay, next person. Um, Sienna. Sienna, according to the coefficient of x squared, would you say that this graph is a maximum or a minimum?
I would say that is a minimum.
You would say that is a minimum. I would agree. Because a is more than 0, right? You see now, right? A is more than 0.
Yes, it is one.
Right. So, guys, if we are positive, if we are happy, would you be smiling or frowning? What would you be doing? Granted, it's not masochist.
Myron.
Be smiling. Guys, does this look like a minimum or a maximum? What do you all?
Minimum.
Yeah, that look like a minimum, right? That look like a minimum. So here it is. We know where the graph is gonna cut the x-axis. We know that it's gonna be from what's it? We know it's gonna be smiling, so a minimum. The only thing we need to find again is the what? Can somebody tell me? What else do we need to find?
The y-intercept.
Perfect. And the y-intercept is simply given by what value over here?
-15, which is C in the equation.
Exactly. But see, Anna, you know why? Do you know why?
Yeah, because isn't it? Because C is the y-intercept in the equation.
Right, but you know why? You know why though?
Uh, Um,
Okay, think about this, right? At the y-intercept, what is the x value equal to?
0.
So if I put 0 into this, right? You're gonna end up with 0 squared minus 2 by 0 minus 15. What are you gonna get? We're gonna remain with. Tell me, Sienna, what are you gonna remain
With
with?
equation the -15.
Right. So once once it has x in it, It's going to turn to 0. And that's why the y-intercept is just the c value, because that's the constant value now. It wouldn't be affected by the x.
Oh, okay. Okay.
So like no matter what quadratic equation you have, wouldn't you always have a constant term? Wouldn't the third term always be a constant term?
Yes, sir.
Yeah, and so the x wouldn't affect it. And so it will always be that will always remain. When you plug x is 0, always remain. And that's why it's the y-intercept. So I feel like now we could sketch the graph. What do you say?
Yes, sir.
All right. I want you guys to tell me where you think I should position it. I want you all to tell me. So like, how we feeling about this? Yeah or no? How you feeling about
No,
that?
sir.
I hear no. How about the rest of you guys?
Sir.
And it would be nice if one of you all could tell me why this is wrong. Why is this wrong?
I could say or there's only the form for.
You could say,
So because the two x values, the two roots is like one is positive and one is negative, and the y-intercept is negative. So it'll be on the opposite side.
yes. One of the form for people. Nia, you there?
Yes, sir.
Right, Nia, what are the x values?
5 and -3.
Yeah, but if I put the quadratic in quadrants, well, I should probably explain that. So like this would be called quadrant 1, quadrant 2, quadrant 3, quadrant 4. So Nia, if I put my quadratic curve in quadrants 2 and 3, um, are any of the x values positive? Look at that for yourself. Are any of the x values positive here? Okay, yeah, a little confused, right? A little confused?
A little bit, yeah.
Okay. Uh, do you know what value this would represent over here? At the center,
0.
0. Everything to the left of 0 will be a positive number or a negative number.
A negative.
Right, so are any of these x values here, according to how I draw it, positive? Say that again?
No.
No. And over here, if you notice, one has to be positive, yeah? You see that?
Yes.
And one has to be
Negative.
right. So I cannot draw my graph in the second and third quadrant. That's wrong. Nia, would this make more sense?
Yes.
Okay. This root over here would be positive or negative.
Positive.
And this one will be?
Negative.
And the y-intercept supposed to be what?
15.
Not 15. Check it out. What is it?
On -15.
Right. So be over here, right? So let's put down our labels, shall we? So this is going to be -3. This is going to be 5. And this is going to be what? Could anybody tell me? What would this be? Anybody?
-15.
Yeah, -15. Christian, you find any of this hard?
No, sir.
You find it hard or like it manageable?
It manageable, sir. Actually, no, sir. It easy.
That's what I'm saying, right? It really not that hard when you think about it. Maths is just look intimidating, but once you get somebody to guide you along the process and you figure it out for yourself, it actually becomes kind of fun. Because now it's like, okay, I want to do a question for myself. I want to see if I could do it. You know? So
Yes, sir.
we are done with factorizing simple trinomials. All right. We're done with factorizing simple trinomials. And a simple trinomial is just when a is 1. So let me show you guys how to factorize quadratics whose coefficient of x squared is not 1. Factorizing. And how would you write this mathematically? Well, I would say that A is not equal to 1. Anybody confused about the word coefficient? Anybody? If you understand, please unmute and tell me so I can move on. All you understand what coefficient means?
Yes,
If
sir.
Yes, sir.
Yeah, Christian, Sienna, yeah? Okay.
Yes, sir.
Yes, sir.
So in all the examples we've dealt with so far, you weren't seeing a number in front of x squared, but it was understood to be 1x squared. And we know how to factorize that case. It's really simple. So let's look at some harder examples. And we're going to employ something called the AC method. Have any of you guys ever heard about the AC method before?
So
No, sir.
Nah? Okay.
so why did you use the term hard?
Hard.
Should I? Yeah.
It's it involves an extra layer of work,
Mm-hmm.
meaning that you have to do factorization by grouping.
Oh,
It
okay.
adds an extra dimension. Now, I'll be honest, when I started teaching maths, I never used the AC method. I would just look at it and figure it out. And I would have taught my students, my prior students, that method. But
Faster?
after teaching for some time, people prefer the AC method. Because it's like, you don't have to guess. You get the answer one time. But
Oh,
if you're down, I could show you the cooker method that I think that I like to use.
well, you show me after class.
Yeah.
All right,
So,
sir.
AC method. Guys, could somebody just remind me the form of a quadratic quickly? Quickly.
EX squared plus BX plus C.
All right. I was hoping for a form 4.
Oh, my bad.
Yeah. Form 4 is, did you all know this? AX squared plus BX plus C.
Yes, sir.
Yes, sir.
All right. So you're seeing AC method. That means this method is going to involve the A value and the C value. Let's look at an example. Suppose we wanted to factorize 2x squared plus 7x plus 6. When we look at this, guys, tell me, what is the value for A? What is the value for A here? Can anybody tell me?
2. 2.
I hope everybody can see that, right? The number in front of x squared is 2, so that's A value. Cool. So this isn't going to be as simple as the last one. Let me show you how the AC method works. We're going to look at the A term, and then we're going to look at the C term. My C term is 6. If you're confused, we're just comparing this to this. Could somebody tell me what B would be?
7.
7? Okay, great. Let's multiply A by C. If I multiply A by C, what am I going to get? Could somebody tell me? What is A by C?
12.
Y'all are getting 12, right? Cool. The next thing we're going to do, we're going to ask ourselves, are there any two numbers I could use that would multiply to give me 12, but add to give 7? That's what we want to figure out now. So what are two numbers that would multiply to give me 12 and add to give me the middle number, which is 7? So guys, think of two numbers that would work for this.
So form 5 can answer or no? Just
Nah,
only form 4.
I want the form
Alright.
first answer.
All right, okay.
You're not good standing, right? You're not good standing. I feel like you and Nikolai and
Nah, sir, I don't think I could.
I think you're not relatively good standing comparatively. Like you, Samir, Nikolai, I think all are fine. I think all are more than capable again a 1 at this point in time. I think so. So I'll ask the others, right?
I said,
So 3 and 4.
3 and 4. Let me call upon somebody else. Nia, do you agree with 3 and 4?
Yes, sir.
Okay, I agree with 3 and 4 as well, because 3 by 4 is positive 12, and if you add 3 and 4, you get 7. So this is the next step. So originally we had 2x squared, and you know what? We could call this we could let this be equal to f of x. I'm just letting it be equal to f of x because f of x is a function. It's just the notation for the function. So if I want, I could rewrite f of x as 2x squared. And somebody, instead of writing 7x, what could I split up 7x into? Think about it.
3 and 4, sir.
Excellent. Christian is trying to pull my leg. I feel like you're secretly good at maths, you know.
I mean, I'm all right at it. I'm not good, and I wouldn't say I'm bad. I just all right in the middle.
That's good. That's good. But you all saw that, right? Sienna, Jashon, everybody in class. 7x is the same
Yes, yeah.
thing as 3x's plus 4 more x's, 7x. Right. Next thing we're gonna do, we're gonna be like Trump and put on a border. Right? We're gonna be like Trump. We're gonna put on a border and we're going to use factorization by the greatest common factor on either side. And then we'll do factorization by grouping. So Sheena, if you look at this side over here, 2x squared plus 3x, what is the greatest common factor? Sheena, let me know if you're there. Okay, I'm hearing Sheena. Akira, are you seeing a common factor between 2x squared and 3x? Okay, I'm hearing.
Yes, sir.
Right, so what is the common factor between 2x squared and 3x?
X.
Yes. Okay, if all you're confused, I want you to tell me, right? Who here is having a hard time seeing the common factors? If you are, please let me know. Kaylee, Christian, Nia, Jashon, Sienna, are you all having a hard time seeing the common factor?
No, sir.
Nah, so I understand.
I have trust issues, so let me just explain it, break it down, right? 2x squared really means 2 by x by x. And 3x is just simply 3 multiplied by x. When you look at these two terms, what do both of them have in common? Could somebody tell me? What do both
They
of them
X.
both
have in
have
common?
X, sir.
They both have x in it. So if both of them have x in it, I could pull out a x. And if I pull out the x, what would I write on the inside? Somebody tell me, if I pull out the x, what would I write on the inside?
The
Hmm.
2, sir.
I'd write 2. Yes. Waiting. We not finished yet. We're not finished yet.
2 times 3, sir.
Nah.
2x plus 3.
2x plus 3. So observe something. We pulled out an x from 2x squared. We pulled out an x from 3x. So if that's the case, we still have 2 multiplied by what? Christian, we still have 2 multiplied by what?
2 multiplied by X, sir.
Yes, which is 2x. So over here now, we're going to pull out x. It's going to be 2x over here, and it's going to be plus 3 over here. Let's look at the other side of the wall. Other side of the border. So, what is the greatest common factor between 4x and 6? By the way, guys, I don't support Trump. Yeah, I don't support segregation and whatnot. I believe one love. Um everybody should love each other and no segregation. But 4x and 6. What's the greatest common factor there? Could anybody see it?
2.
Yes. Okay, if you're confused, right? Watch this. I can write 4 as 2 by 2 multiplied by x, and I could write 6 as what? Somebody tell me, what do you think I could write 6 as? Those are 7, eh? What could I write 6 as? Nikolai, what?
2
2
by
by
3,
2 by
sir.
2.
Nah, I could write 6 as 2 by 3. I could write 6 as 2 by 3. What do you notice in common between this and this? What do you
They
notice in
both
common?
have two, sir.
They both have 2. So I'm going to pull out the 2. And if I pull out the 2, what am I going to write inside? The brackets. So I pull out,
2x plus 3.
yes, 2x plus 3. Because if I pull out the 2 from here and here, I'll still have 2x over here, and I'll still have 3. Great. So I'm going to pull out the 2, and as such, I'm going to write 2x plus 3. Can anybody notice that there's a 2x plus 3 here and a 2x plus 3 here as well? Are you all seeing that?
Yes, sir.
Cool. So if I'm seeing 2x plus 3 in both places, then here's my question. Are you all seeing anything in common between this and this? Is there a common factor? Are you all seeing anything in common between both of them? Keely, are you seeing anything in common between both of them?
Well, so they are the 2x plus 3x and the 2x plus 3x on the other side, they're the same.
You said 2x plus 3x. Where you see the...
2x plus 3. Sorry, sir, sorry.
That's okay, but Keely, the point is you're seeing 2x plus 3 over here, and you're seeing it over here as well. So the greatest common factor between those two terms is actually 2x plus 3. From there, what am I going to write inside the other bracket? Tell me,
So we
Keely.
write x plus 2.
Yep, x plus 2. Is there anybody that felt as though they didn't understand it? Tell me. Be honest with me. Is there anybody in class that felt as though they did not truly understand it? If you didn't, tell me, and I'll try to explain it back.
So you could just explain over the last part.
Oh, who's this?
Sienna.
Okay, no problem, Sienna. So, Sienna, after you pull out the greatest common factor from here and here, we were left with x by 2x plus 3 and 2 by 2x plus 3. Are you
Oh, so
noticing, anything in common between them?
yes, so it has two x and both brackets.
Right. So, I mean, I hope you can see it, right? This is like the same thing as this. It's the exact same thing. You're just pulling out the greatest common factor from both. Make sense?
Yes, sir.
Nice. So, I'm going to give you all a chance to copy this down. Long story short, with the AC method, you're going to multiply A by C. You're going to get a number. You're going to try to figure out two numbers whose product would give you um the middle term. What's in? You're gonna figure out two numbers whose product is gonna give you the same number and whose sum is gonna give you the middle number. So I hope nobody's confused. In this question, we got 12. Now, to get back 12, you'd have to multiply 3 by 4. You'd get 12. And if you add 3 and 4, you'll get back 7. And so that's why we use 3 and 4. Once you've figured that out, you are going to split the middle term into a sum of these two numbers. So 3x and 4x. And then you're going to be like Trump and put on a border, and you're going to pull out the greatest common factor on both sides. Hopefully, if you've done everything correctly, you're going to see that there'll be something in common between both of the terms. Once you could see that, you're going to pull that out, and that's going to give you a final result. That's factorization using the AC method. So copy this down, and I'll give you all a question. Matter of fact, I'm going to give you all a question now, because I feel as though some of you already understand this. Um, so for those who feel like they understand this, I would like you to try 3x squared so f of x is equal to 3x squared plus 9x plus 6. I would like you all to try to factorize that using the AC method. Yeah, guys. Christian, is there anything here that's confusing you? So you think you could get through with number two by yourself?
Yes, sir.
Okay, I like to hear that. Akira, Jashon, Kaylee,
Yes.
yeah, we good? Or no?
So,
Right?
Yes, sir.
Nia, how you feeling?
I got sir.
You sure nothing confusing you?
No, I actually handle it well, I think.
You think? Okay, well we go see, right? We go see for sure. Sorry about that. I was blocking the text. So here, we'll take 2 more minutes, copy down everything, and you can attempt number two by yourself. So I'm going to give you in 4 minutes altogether. And in that 4 minutes, after that 4 minutes, we are going to move on. Here what? If you think you genuinely understand what was taught last class, I would like you to sketch the graph. So if you feel like you understand it, I'd like you to sketch the graph for numbers 1 and 2. So you could go ahead and try that. Amira, you in class? Wonder if Amira is in class. Amira, how are you?
Yeah, I'm okay. How are you?
I good. It's been ages. I feel like I never seen you in so long. Like I low-key thought he wasn't coming back, you know. I know I low-key thought he wasn't coming back.
No,
Yeah,
so February was like a really, really busy month. So like it
I
didn't make
understand.
sense.
I understand. With SBS and stuff.
Yes, sir, and so school just
You know how to tell me you killing me right now. Yeah, boy, school just yeah.
so
So
I
yeah.
feel
Oh
the
yeah,
worst subject.
say that again.
So I feel like I picked the worst subjects.
What subjects you pick?
So I doing physics, art, maths,
No, no, no.
geography.
We's not friends anymore. We's not friends anymore. I will say like them is my favorite things, boy. How you go disrespect it like that? So,
So
come
I
on.
don't know. You see physics? Nah, so I actually can't. I actually can't.
Okay, you know about my playlist on YouTube? On
Yes.
okay, if you watch our playlist, you will find it hard. Okay, I promise to check it out. I can't say for sure that you will understand, but at least I go very slow and I take my time. Maybe you might understand. No promises, but I will send you back the link and you give it a watch and see if you understand anything. Physics.
Okay, so this weekend, so I will watch it and I'll come back to you next Tuesday and tell you if like I reach anywhere.
Okay, but in my humble opinion, physics is one of the easiest C-Sec subjects. Like you say, you had to slave
That is
yourself.
a lie.
No,
So
no.
that is a lie.
Hey, I had a student who was 38 years old, never did physics in their life. Didn't do school in so long, never do a lab. They do physics between 3 months and they get a two. They had to write a paper three, and they still get a two.
So
Physics.
I think it's just my teacher because she don't really like teach, like she just put in notes there. And I feel like physics
Oh,
is not something that
no,
I
no,
could just
no.
like, teach yourself. Like I need to do it in order to understand it.
Yeah.
And she didn't really do that.
Well,
So
that's the problem there. That's the problem.
so right now I asked my mom to join her physics lessons, but eh.
Well, if you join the
Anyway.
physics lessons, there'll be a discount, you know. Be a discount.
So like if any maths, any physics.
Yeah, like instead of paying 250 per subject, it'll be 200 per subject. Yeah, so before
Okay,
$400.
so
Had to incentivize it a bit. But genuinely speaking, physics is really fun. If you actually okay, if the teacher doesn't just write down notes and tell you to copy it down, they actually can have fun.
so
What
that's why I picked it because in phone like I had a different subject and I was actually good at it. Like so I used to be getting 90s and thing. And then as soon as I come in phone for like my math just drop into 60s and I don't know.
hmm. Don't worry. I sent you a video, Snell's law and refraction. You could know nothing, and after you look at it, you might know something. Trust. Trust.
Okay, so
All right. So the time is up. It's nearing end. Serena, you want to see how I would do that in my head really fast? All right, so Serena, check this out. This is what I just do. So like I would look at the first term, right? The first term is 3x squared. What are two terms I could multiply to get back 3x squared? Tell me, Serena. What could I multiply to get back 3x squared? Serena,
3x and x,
right? I want you to look at the last term. What's the last term?
6,
We can multiply to get back 6.
2 and 3.
2 and 3 wouldn't work. I can tell you that from now. 1 and 6 could work, right?
Oh yeah.
Let me see if this will work, right? So this is what I would do. It looked like it will work. Maybe if we switch it around, but right now, 3x will multiply by the x, you get back 3x squared. The 3x will multiply by the 6, you get 18x. So this can't work. Because you're supposed to get 9, right? So what if I now switch positions? Will it work now? Let me see. So the 3x would multiply by the x, you get 3x squared. The 3x will multiply by the 1, and you get what?
3x,
And the 6 will multiply by the,
x, and you get 6x,
and when it's 3x plus 6x.
9x.
Right? And you get your answer one time. This is how I would do it. I just simply look at the first term. I try to figure out what ways I can multiply that. And then I just look at the last term and do the same thing and just, but it's kind of guesswork. It's kind of guesswork. After I do it for a long period of time, it becomes intuitive. But I see why students would prefer this method because it's a safer method. But if you could learn that skill, you'd be goated.
So I used to do this before, but now I get accustomed to just doing the AC method. So
I see, I see. I mean, it's the safest thing to do, eh? It's the safest thing to do. Yeah. I like what I'm seeing, guys. I like what I'm seeing. Everybody seems to be doing the correct thing. Christian, I want to see what you're doing. Christian, I want to see. Amira, since you wasn't here for this, you'll do question two with me. Yeah, you'll do question two with me.
Okay, sir.
Promise it easy. Christian, you there?
Yes, sir.
Did you get a chance to try it? Oh, Nia, I had a good answer from you too, right, Nia? Nia,
Mm,
waiting. Christian and Nia.
Yes, sir.
Okay.
For the rest of you guys, I want you to go a step further and I want you to sketch the graph for this. So I want you to sketch the graph. So sketch the graph. Sketch the graph of f of x. That's what I want you to do. And when I see a sketch the graph, I'm expecting to see where the roots are, and I want to see where the y-intercept is. These are the things I want to see. So those that are done with number one, please go ahead and do that. Well, number one, I do it with you, so there wasn't anything to do. But see if you can sketch the graph for both of them. So Serena, see if you can sketch the graphs. Nia, be honest with me, things looking good or bad?
They looking all right.
All right. Well, I'm looking for the answer. I'm not seeing it. I'll wait and I'll wait.
Yeah.
Come on, lock in, lock
Okay.
in.
I'll try, sir.
Okay, how far are you along your process?
On the second to last step.
Okay, Christian, what about you? How far are you from the process, like into the process?
So on the last step, so but like so do I send it on take a picture and I send it on WhatsApp. So I'll send the answer in the chat.
Send it to my WhatsApp.
I have a
Okay.
question. What question are we doing? I was doing something from
I
just doing
want
from my
you to
computer.
do number two for me, right? And when you're
All right.
finished doing number two and you factorize it, I then want you to sketch the graph for it.
All right.
Your sketch should include the roots as well as the y-intercept.
Okay, sir.
Okay, Christian, that would not be correct. Yeah. I'm asking a question, Christian. Um, okay, here what? When we do the question, you'll see why that's not correct. But Okay, can I give you a hint? Christian, do you know why I was able to pull out 2x plus 3 from both of them?
Because on the side of it, you did 2x by 2x by x. No, 2 by x.
Not quite. The reason was because both of them had 2x plus 3. I could have pulled out 2x plus 3 because you see a 2x plus 3 over here and a 2x plus 3 over here. Aren't they the same thing?
Yes, sir.
So if you have the same thing in common between two terms, you could pull out the common term. But if you look at your work in there wasn't a common term. There wasn't a common term. Thelma, is 3x plus 3 and 2x plus 3 the same thing?
No, sir.
Nah. And the next thing. I see you write 3x plus 4x. What that's supposed to be? You could do it, man. You
Yes,
could do it.
sir.
Yeah, check it out. I see you write f of x is equal to 3x squared plus 3x plus 4x. Yeah, boy. You gotta be careful. All right, Zakira, no problem. It was good having you in class. Take care.
Yes, sir. I'll be here for the Form 5 class. So.
Lessons. Go eat some food. You don't want to look like
Yes,
Kubla
sir.
Singh. You
Bye.
want to look like Kubla Singh.
Yeah.
All right, later.
Bye.
Okay, so Adrian, I see you just joined it. All right.
Yes, sir.
Adrian, what's your plan? You good?
Yes, sir. I'm good.
Okay, nice. So you join in the middle of things, but don't worry, the process isn't hard. Stay with us and you'll see it's actually not that hard to understand. If at any point in time you feel confused, just let me know, right? So,
All right, sir.
Amira, there we go. So, Amira, anytime the coefficient of x squared is not 1, you should probably use the AC method. So, first things first, Amira, you know what coefficient mean? You know what I mean? Tell me, Amira. Coefficient.
Yes, sir.
All right, so
So
what is the coefficient of x squared there?
3.
Right, so coefficient is just the number in front of a variable. So 3. Now, quickly, I want you to tell me what A, B, and C is. See if you could figure out what A, B, and C is.
So A will be 3,
Right?
B will be 9, and C will be 6.
If there's anybody in class that's confused, this is in the form of a quadratic. Now, a quadratic is being this form, ax squared plus bx plus c. So if we compare it directly, a is 3, no, b is 9, and c is 6. Awesome. Now, in the AC method, you're going to multiply the a term by the c term. So tell me, Amira, what is a? What is a?
3,
What is the c term?
6,
What's 3 by 6?
18.
Right? Now, here what we're going to do, right? Here what we're going to do. We're going to try to figure out two numbers that would multiply to give 18 and add to give me the middle term, which is 9. That's what we want to figure out. So think to yourself, what two numbers would multiply to give 18 and add to give 9? Think to yourself, what two numbers would do that? So tell Mira, what are some numbers you could use to multiply and get 18 back?
So you could use the same 3 and 6.
Yeah, you could use 3 and 6. Adrian, what's 3 by 6?
18.
Right? So stay with me, right? In the AC method, you're taking the A term, which is just the term in front of the x squared. A is 3. You're taking the C term, which is the last term, 6. You're going to multiply it. You get 18. We are trying to figure out two numbers whose product would give 18 and whose sum would give the middle term, which is 9. And as you guys would have saw, 3 and 6 was your right choice. 3 by 6 is 18. And what is 3 plus 6, guys? Amira, what's 3 plus 6?
9.
Great. So, Amira, if that is the case, I could rewrite my middle term as what instead? Instead of me writing 9x, what could I write?
18
Nah, you
or
can't write.
3 plus 6?
Yes. 3x, you can't say 3 plus 6, eh? It's 3x plus,
6x.
right. Adrian, I hope you're not confused. Like, all we did, right? So, Adrian, do you understand that 9 is just the same thing as 3 plus 6?
Yes, sir.
Right. Imagine you had 9x's. I don't mean that in any literal sense. Right? Imagine you had 9x's. And you split up that into 3 and 6. And altogether, it would have 9x's.
9. Yes, sir.
Right. So, all I'm doing here, I'm just splitting up 9x into a sum of smaller terms. So, 3x's and 6x's. So, Amira, let's continue. I'll write back the plus 6. Amira, then we're gonna put on the we're gonna put on the border like Trump. Right? We're gonna put on the border in the middle. We're gonna split it in the middle. And we're gonna look at what's on the left side and the right side of this border. So, Amira, look at 3x squared and look at 3x. What do they have in common? What is the greatest common factor between them?
3
Not just 3.
x, 3x.
Yes. Now, I want everybody to pay attention to this, right? Especially Christian. Christian, pay attention. Let me show you a way to understand this. Amira, if you see 3x squared, that's really 3 multiplied by what? What does x squared mean? Tell me, Amira, what does x squared mean?
That you multiply x by itself.
Right, so x by x. So we have 3 by x, and that represents 3x squared. Then I have plus 3x, which is just 3 multiplied by x. Guys, what do you notice that is in common between this and this? What do they have in common?
3 and x.
Are you seeing that right? I have a 3 by x in common here with this. I'm wondering if you're seeing that or no. Are you seeing that or no?
Yes, sir.
So if that is the case, Christian, what are we gonna pull out?
The 3 and the x and the 3 times x.
Say that again?
The 3 times x plus the 3 times x.
No, we're just gonna pull out 3 times x. I think you're seeing it. I think you have the correct idea, but you're just seeing it wrong. So like all we do in Christian, since it have 3 by x here and it have it over here as well, you're gonna pull it out from both of them because both of them have it. Now 3 by x is really just what? What's 3 by x? 3 by x is what?
Yes.
3 by x is just 3x, right? So I'm gonna pull out the 3x. If I pull out 3x from over here, what am I gonna write in this bracket? Tell me, Amira. So I pull out the 3x from 3x squared. What am I gonna write in bracket?
Um, 3x,
Nah. What, right?
3.
No. Look at it for yourself, right? Check it out. 3x squared is the same thing as 3 by x by x. And 3x is just 3 by x. What do both of these terms have in common?
3 by x.
Right, so you pull out the 3 by x. So then, what am I going to write for this?
X.
Yeah, x. And let me show you something. Whatever you put inside here, the product is supposed to give you the original term. You might be a little confused, but watch it for yourself. What is 3x by x? Tell me. Tell me, Amira, what's 3x by x? Amira, what's x by x?
X.
Nah, x squared.
Oh. Oh.
Yeah,
Okay.
say, let me correct ourselves. So what's 3x by x?
3x squared.
Right, because you're multiplying x by itself. So you see, you get back to your original thing. Now,
Okay.
next question. Now you're going to move on to this, and you might be tempted to say 0. Are you tempted to say 0? Okay, who here is tempted to say 0? You might be tempted to say 0. That'll be wrong. Amira, you understood this part, right? I pulled out 3 by x, so I just wrote x in the bracket.
Yes, sir.
I want to multiply 3x by x. I'm supposed to get back what? What am I supposed to get back?
3x squared.
Right. So now I want you to ask yourself, what should I put over here so that when I multiply it by 3x, I'll get back 3x? What by 3x is 3x?
You have to put back a 3.
Okay, let me see what happened if I put a 3, right? What's 3x by 3? You tell me, what's 3x by 3? Think about it. 3x by 3. Does it give us back 3x?
No.
What does it give us?
9x?
Yeah, that does do it over that. We want back 3x. Yeah.
Put back 1.
Yes, that is it.
Okay.
That is it. Yeah. And if you expand the brackets, you're supposed to get back 3x squared plus 3x. Watch. 3x by x. 3x squared. 3x by 1. 3x. Get back the original thing. Christian,
Okay.
are you still confused? If so, let me know. I'll go it over again. But you had to tell me.
Well, I think I understand, sir, but you could go over it one more time just to make sure.
All right, no problem. No problem. Adrian, I want you to be real honest with me. Like, you're confused? Can I scale of 1 to 10, like you're real confused?
Oh, 7.
You're like 7 out of 10 confused?
Yeah.
Okay, no problem. Did you do this in school as yet?
Sir?
Did you get a chance to do this in school as yet?
Yes, I am actually resitting.
Oh, okay. I see.
Yeah.
So this will be a little while then. Factorizing quadratics.
Yeah.
I see. Well, check it out again. We'll do a question together just now, but for this question, Christian, our way to focus, right? So Christian, 3x squared. That is the same thing as 3 by x by x. See now, Christian?
Yes, sir.
Right? And 3x is the same thing as 3 by x. What do you see in common between both of these?
3 by x, sir.
Right. 3 by x. Can we both agree that 3 by x is just 3x?
Yes, sir.
Right. So I pull out 3x. Why? Because both of the terms had it in common. That's what greatest common factor means. It means that they have something in common. You understand?
Yes, sir.
So if I pull out the 3x from this term, I would write x in this bracket. You see that?
Yes, sir.
Because when I multiply it out, I'm supposed to get back 3x squared. So what is 3x by x?
3x by x is 3x squared.
Right? And the next thing, this part might confuse you. Notice, right? We pulling out 3x. So you might be tempted to put 0 over here because I pull out everything. And that's what you're thinking, right? Probably. I don't know. Let me know what you're thinking.
No, sir. I'm thinking that the x there will be 1 because x is just 1.
I think you're thinking about it wrong. The proper way to think about it is like this. Check it out. What is 3 by x divided by 3 by x?
0.
Nah. How much times 3x could go into 3x?
1.
Exactly. It's 1. So like, this is another way to think about it, right, Christian? When you pull out something, it come like a dividing throughout by what you're pulling out. Watch this. If I divide 3 by x by 3x, what's gonna cancel off?
The 3x
And leave me with what?
by x.
You just leave me with x, right?
Yes, sir.
And if I divide here by 3x, I'll just leave me with what?
1.
Right. Now, An even simpler way to understand this, whatever you have on the outside, when you multiply it by on the inside, you're supposed to get back the original thing. So, Christian, what would I need to multiply by 3x to get back 3x? What would I need to multiply by 3x to get back itself?
Itself, sir?
Nah, if you put 3x over here, 3x by 3x, it's going to be 9x squared. You're not going to get back 3x.
Negative, no.
Wait, so Amira had told me, so you should put 3. If I put 3x by 3, what's 3x by 3?
9x?
9x. Do we get back 3x?
No, sir.
No. So keep going down. Keep going down. Maybe you could try 2. Where's 3x by 2?
5x.
Nah, not 5x.
No, 6x, my bad. Yeah.
Maybe okay, then we could go down to 1. Where's 3x by 1?
3x.
Right. So just 1. You gotta put 1 to get back 3x. You understand?
Oh, yes, I understand.
Okay, so I want you to help me with the other one now. So look at 6x and 6. What is it? What are you seeing? What are you seeing in common between 6x and 6?
6, sir?
Right. So what am I gonna put inside the brackets now? Like if I pull out 6 from 6x, what would I need to put here to multiply by 6 to give me back 6x?
6 plus 1?
Nah. So whatever we put in this bracket, it's supposed to multiply out to give me back the original terms. So
Wait, no, x plus 1, sir?
yes, x plus 1 is correct. Because with 6 by x?
6 by x is 6x.
Lovely. And with 6 by 1?
6.
You see, you understand it. Nice. Now, Amira and Christian, are you all seeing anything in common between this term and this term? Do they have anything in common?
Yes, sir.
What
Yes,
do
sir.
they
X
have in
plus
common?
1?
Right, they have x plus 1 in common, which means I could pull it out from both of those terms. So what would I write inside of that bracket?
3x plus
Plus
6.
3x plus 6. Yep, 3x plus 6. Mm-hmm. We understand that?
Yes, sir.
Yes, sir.
Nice. Nice. Adrian, you can do a question moment just now, right? Serena, you there?
Yes, sir.
All right, Serena, did you get a chance to sketch the graphs?
Yes, sir, I did. I think I sent it to you.
Okay, no problem. I'll check it just now. Is there anybody in class at this point in time still really confused by the AC method of factorization? If you understand at least, let me know. I would appreciate that. Do you understand?
So I understand.
I
Yes, sir.
understand.
Okay, good. So let's try to sketch the graphs now. So, Sienna, to sketch the graphs, it is the exact same process as last time. So, Sienna, if we
Yes,
want to
sir.
figure out the roots, I'm going to put the product of my factors equal to what?
0.
Right, I'm going to put the product of my linear factors equal to 0. And why? The reason I'm doing this is because the roots is the what intercepts. The roots is the what intercept.
X-intercept.
And the x-intercept, where's the y value or the f of x value?
0.
Right. So you understand that I just replace f of x with a big 0. Yeah?
Yes, sir.
And so now we're trying to figure out the values of x that would make the individual brackets equal to 0. So I suppose this one real simple. Where do you think x would have to be to make that bracket 0? Look at that one and tell me. Where do you think x would be?
Minus.
Yes, -2. That is correct. Adrian, Adrian, you there?
Yes, sir.
A simple question for you, Adrian. What number would you multiply something by to get 0 every single time? What number would you have to multiply something by to get 0?
A number.
Was it okay? Let me just say 5 multiplied by something to get 0. What would I need to multiply 5 by?
0.
What about 7 to get 0? What do I multiply that by?
0.
So anything by 0 is
0.
right. So over here, I have 2x plus 3, that's one bracket, multiplied by x plus 2, that's another bracket. So Adrian, if you look at this bracket, right, what value of x would you replace x with to give you 0? So like, imagine you replace x with some number. What plus 2 is 0?
0. 0.
So
Negative.
you're along the correct path. Negative what?
Negative 2.
Yes, that is correct. Negative 2 is the opposite of plus 2. Will give you 0. And that will make this whole bracket 0. And well, 0, we don't really care what we have in this bracket, right? 0 by anything is 0. So, Adrian, that's the concept of this. We're trying to figure out what values of x would make the equation equal to 0. So you just found our answer, right? X is equal to minus 2. It's one of the answers. So,
Yes, sir.
Sienna, let me continue. So, Sienna, to work this out formally, I would put each linear factor equal to 0. So I would say 2x plus 3 is equal to 0. And I would say what for this bracket?
X plus 2 is equal to 0.
Right. This one real simple, right? You know the answer going to be what?
Minus 2.
Right. Because to get 0, you'd have to say negative 2 plus 2. Cool. How would I solve this one?
You're going to move across the 3 to the other side. Well, across to the other side of the equal sign, and it'll turn to negative 3. And it'll be
Right.
2x is equal to negative 3. And then you'll divide both sides by 2. And you'll get negative 1.5.
Excellent. But here what? We can leave it as a fraction, right? We can leave it as a fraction for now. 2 into 2 is 1, so that's going to just leave us with x. And yeah, that'll be minus 3 over 2. So we have our x-intercepts or roots. Could somebody tell me what the y-intercept for this quadratic would be? For this quadratic over here, what would the y-intercept be? Can anybody look at this and tell me what the y-intercept would be?
6.
Do you all agree?
Yes, sir.
Okay, if you forget, right? If you forget, at the y-intercept, what is equal to 0? What is equal to 0 at the y-intercept? Anybody remember? X. So at the y-intercept, we know that x is equal to 0. So if x is 0, you're going to end up with 2 by 0 squared. And this whole thing going to be what? What is 2 by 0 squared?
0.
Okay, what is 7 by 0?
0.
What is the only thing that's going to remain?
Plus 6.
That is all. So if you ever forget, just think back to that, right? What we did in linear programming is extremely important. The x-intercept and the y-intercept. Don't ever forget that. Trust me, don't ever forget that. That's important. So this is actually very simple because we know the roots and we know the y-intercept. So I want you guys to guide me as to how my quadratic is going to look like. Do you all find this to be extremely confusing? Or are you guys actually following? I need to know.
Following.
What about the rest of you guys? Do you all find this to be extremely confusing? No. Like, be honest with me. If all you find it confusing, tell me. Yeah.
Yes, so that's kind of confusing, so I'd rather use the other method.
Okay, well, you have to use this method if the coefficient for a is not 1. In all the other examples, Christian, the number in front of x squared was just 1. So we could have applied the previous method. But since the coefficient of x squared is not 1, you have to do it like this. Yeah. So you gotta get accustomed with it. Yeah. All right. So guys, this is our quadratic, right? Does it look like it'd be a maximum graph or a minimum graph? Tell me, guys.
Min
All right, this would be a minimum graph because A is what?
positive.
It's a minimum graph because A is more than 0. Cool. And the y-intercept would be what? Someone just remind me, the y-intercept would be? Hello? Why the silent treatment? We know what the y-intercept is. What's the y-intercept for this?
6.
Yeah, it's 6. You're just looking at the C value. Cool. So I want you all to guide me, right? Would this be correct if I draw this? Yeah? No? Extremely wrong? Extremely right? What that would
Extremely
be?
wrong.
Yeah, I doing nonsense. That's utter nonsense. Could somebody explain why that would be utter nonsense?
So because you're drawing a maximum graph and we supposed to draw a minimum graph because the A value is more than 1.
You see how you correct me like that? I want to let you correct all yourself like that in the exam. As important. I'm not saying now attitude, I mean I'm being real. Because that's the kind of mistake students would make in the exam. Yeah. Okay, so we know that the graph's supposed to be a minimum. We know that. We know it should be looking like this. Tell me, is this placement correct? Look at my x values. Is this placement correct?
No,
Could somebody tell me why this placement is not correct?
because that's on the positive side.
I love that, Nia. Clock it, clock it. Right? Both of my values for x are what? Both of them are what?
Negative.
Both are negative. So wait, what are you doing over there? Alright, what are you doing over there, right? Does this look correct?
Yes.
Yes. Now, which one is smaller? -2 or -3/2?
Negative. True. 2.
Well, why had I asked you again? Like, which one's smaller?
Yes.
Yeah, -2 would be smaller. Because it's more negative now. Like, -3/2 is -1.5. So, what I'm trying to get you to tell me is, like, which one would gonna come first? Which one am I gonna put first? -1.5 or -2? Which one am I going to put here?
1.5.
Yeah, yeah. It's okay if you're confused. We're gonna do a bunch of more questions. It'll be fine, provided you're lucky. If you don't lucky, you're cooked. Okay, somebody other than Nia, what am I going to put over here? And what do I call that point? What do I call this point?
The y-interception.
Excellent. And what did we say the y-intercept value was?
6.
Yes. Perfect. Good job, man. Cool. So you can take a screenshot of this. Let's do this exact same process for question 2. After, I'm going to give you all a question to factorize by yourself, sketch, and yeah, sounds like a plan. The next thing we have to look at is the quadratic formula. We also need to look at completing the square, and then we could start past paper questions on quadratics. We should be fine. It gets particularly complicated when you start to do worded problems, like the seedbed problems in the exam. Oh, you know what I'm talking about? With the seedbed question, like you have a garden and the area of this is equal to the area of that for my equation. Anybody know what I'm talking about?
Yeah, I had one of those in my papers, in my paper, 2 questions, and I Didn't know what to do.
Yeah, boy, it's be a bit tricky. You have to read the question to formulate your equation, and it's only then you could solve it. So it's be tricky. So I take it that you all have a screenshot. Let's do the exact same procedure for question 2 now, quickly. Or they're probably saying, way boy, I real forgetting about maximum. Don't worry, I'll give all you a maximum question just now. I need a volunteer to help me with this one. Any volunteers? Any volunteers? Any volunteers? Do I have any volunteers? We want to sketch this. I'm
Me,
gonna
sir.
call. Okay, who's that? Serena?
Serena. Sheila.
Okay, that'd be pretty bad if I didn't know your voice, considering you're my star pupil and all. Yeah. So Serena, let me find the roots first now. Let's find the roots.
Yes,
How am I
sir.
going to find the roots?
First, we put the brackets equal to 0.
All right, so we're
So,
gonna put the product of linear factors equal to 0. Question, do you know why I call them linear factors?
because the highest coefficient of x is 1.
Right, and do you know why I call them factors? That's the thing, eh? That's the thing. Like people, like my teachers will be saying a bunch of things, and students will be like, "What is man really saying?" But like, if you think about it, you'd be like, "What's he saying?" That part confuse you. Like when I just say linear factors.
Yeah, I think so.
Let's take a little detour, right? This is really for hard math students, but I think everybody could learn something from this. People in class, if we look at 21, what are some factors at 21? What are some numbers I could use to get 21? Like when I multiply. Well, give me some numbers, guys.
3 times 72.
Right. Now, a factor is a number that could go into another number without leaving a remainder. You could think of a factor as piece of a number now. So like 21. Some factors of 21 are 3 and 7. Because both of them make up 21, and as such they could go into 21 without leaving a remainder. Serena, you just seeing that? And 3 could go into 21 7 times, and 7 could go into 21 3 times.
Yes, sir.
So think about it, Serena. Isn't this what you're gonna be mind blown? You're gonna be like, oh, you're gonna be like, oh. What if I told you we're doing the same thing but just for algebraic expression? Watch this for yourself, eh? Serena, if I were to expand these brackets, what would I get? What would I get, Serena?
You get the 3x squared plus 9x plus 6.
Right? So if I wanted to, like, and I could literally write 3x squared plus 9x plus 6, x plus 1, 3x plus 6.
Yes, sir.
Yeah. When I say it's a factor, I mean that it makes up 3x squared plus 9x plus 6 as y is a factor. And if all they're doing hard maths, all they're gonna know that x plus 1 divided by this, it give me 3x plus 6. And 3x plus 6 into this would give me what? Tell me, Serena.
X plus 1.
Right. So, Serena, you see how things will be looking so complicated, but like it loops back to like the most basics of things, most basic of things.
Yes, sir.
So I hope you understand what I mean when I say linear factor now. All right.
Yes, sir.
Enough for the detour. Let's continue. So then you would say x plus 1 is equal to,
0.
and you would
And
say
x would be
3x.
equal to minus 1. Oh, my
Oh,
bad.
that's okay. And x would be equal to,
Minus 1.
what we're going to do that 6.
3x would be equal to minus 6. And then
Right.
we divide both sides by 3. So you get x is equal to negative 6 over 3, which is negative 2.
Bet. Lovely. So we have your roots. Could you tell me the y-intercept?
The y-intercept is 6.
Right. Could you tell me if it's a maximum or a minimum?
It would be a minimum.
All right. Why would it be a minimum?
Because the A value is more than 0.
Right, the A value is more than 0. So it's going to look like this.
Yes, sir.
Nice. So in the next class, okay, in the next class, do y'all want to do completing the square? Or do y'all want to do the quadratic formula?
Complete any square.
In this question.
Bet, no problem. Because why do you really do complete any square? We do complete any square so we could figure out the highest point of the graph and the lowest point. Because, let's be honest, guys, and we already know most of the things for the graph. Look at that. And we know most of the things. Some of us see it now. Like, what are some things I know about the graph? Oh, do you know anything about the graph?
The roots and the y-intercept.
Yeah, we know the roots and the y-intercept, but and it would be nice if I knew the lowest point of the graph.
Yes, sir.
Yeah, that's why I use completing the square. It's also called the vertex form because you use it to figure out the lowest or the highest point of the graph. So that's the only thing. That's the only other thing you really need to know when sketching a graph. But look back to this question. So Serena, I'm going to draw a smiley face. Number one, that's what I'm gonna do because that's what we're feeling right now. Cooking this thing, it's easy. Um, and people other than Serena, right? Serena, you could answer too, but I want to hear other people. Both of my roots are what? Somebody tell me. Both of my roots are what? Tell me, guys. Both of my roots are what?
Negative.
Negative.
Okay, is this correct? Is this placement correct?
No, sir.
Because in this scenario, both of my roots would be what?
Positive.
Would this be correct?
Yes, sir.
Yeah, that make more sense. Which one am I going to write first? -1 or -2?
-1.
Right. Because -2 is actually smaller than -1. And what am I going to put for the y-intercept?
-6.
Nah.
No, 6. Sorry.
Think about it, yeah? That could have never be -6 because it's above it's above 0 now. It's above 0.
Yes, on my graph, I had the like dash to show that it was 6 because you always have like the dash to show where the point was, and I thought it was negative.
Ah, you tie up yourself there.
Yeah.
I see. All right. So, are we okay with this so far, guys? How we feeling? How we feeling? Feeling good? Let me know. Let me know.
Yes, sir. Feeling good.
All right.
Yes, sir.
I'm not getting enough feedback. Serena, give me some energy. How you feeling?
Feeling amazing, see.
That's great. That's extravagant news. I love that. Nia, how you feeling?
Feeling great.
You sure?
Yeah. Yeah.
One could,
Actually understand.
I was gonna say one could say you're on top of the moon because your profile picture is a moon.
Well,
Yeah.
yeah, I guess on top of the moon. I am the moon.
Yep, you are the moon. You are one with the moon. Have you ever watched Avatar?
No.
No? Okay, okay. Never mind. Um, so Adrian, I suppose you're still confused by some things. Lamano, I suppose you're still confused.
Sorry, because I'm trying to not get the first part.
Say that again.
The first part, the beginning.
Beginning? Okay, no problem. We'll do our question together. Don't worry. Um, Sheena, you feeling good?
Yeah, live.
Yeah, alive? Okay. Okay, you're feeling good about the maths and I guess you're not feeling good health-wise. But you're
Oh
feeling
yeah, so
good.
this was good.
Okay, cool. Nikolai and Samir, are you chilling? It's easy, right? It's like nothing.
Yes, sir.
Nikolai, this ain't even scratching your brain, right? Like this is like, you could do this in like 3 minutes in the exam. Probably less time.
Well, yeah.
As if I remember it. So yeah.
If you remember it, Nikolai, Tivon and I will find you, you know. We go find you, you know.
Nah, nah, nah. Nah, nah, nah. So I go
Yeah.
get you.
Yeah, you bet. I bet on you getting a distinction, you know. No pressure, no pressure. Maybe a little bit of pressure, but if all you see the amount of work Nikolai does be putting in, it wouldn't make sense if you don't get a one. Would not make sense. Yeah. Okay. Let me give you all a question now. If you need to take a screenshot, and let's move on to our question. Adrian, you're gonna do this question with me. The next one. Christian, I'm expecting a correct answer this time, and I believe you could do it. Okay. Do you all have the screenshot? Matter of fact, I'll take a screenshot and
Yes,
send
sir.
you that. I have so much trust this user, but especially when it comes to students. I don't mean in a bad way, but I say that because I know myself. All right, cool. So let's move on to another question. And I'm going to structure this like an exam question. Okay, answer the following. So, number one, state yes. Guys, if you could handle this question, you could get like 5 marks in the quadratic question. You could get like 5 marks. I'm not even joking. So I'm going to give you all 4 minutes, and the time starts now. Amira, I see that you're inside. I'm going to see you for physics. Big up you.
Yes, sir. I went and tell my mommy and she say okay. But so what date is on?
It's on Saturdays, 10 to 12.
Okay.
Yeah. Guys, I wanted to ask a question, right? Just like a survey. Do you all prefer learning maths in a way like I just tell you do this, do that? Or like you prefer to like actually kind of understand what you're doing? I'm curious. Like honest feedback though. Should like a little survey.
I
Anybody?
prefer to understand it too.
Yes, so you prefer to understand it. Because that way you could
Understand
solve any
first.
question once you understand.
Okay. Because like I find as though when I was in secondary school and teachers would just say do this, do that, there'd be very little understanding. And if the question come differently, you cannot be screwed. You don't understand anything really. So like this question, I change up the wording. I changed up the wording. So I want to see now if you all understand what we was doing just now. Because all I did was I changed up the wording and I split it up into parts. That's all I did. It's the same concept as what we did above. So now I'm seeing if you all understand. But I just wanted to do a survey. Yeah. Christian, be honest with me, like this confusing, yeah? Like real bad?
Well, I think I know what to do, sir, but like I, I'm still doing it, sir.
Okay. Do you figure out the why in this up?
No, sir, I still do it. I still trying to figure out what I said.
Okay, it's a good thing I bring I bring it like an exam question. Do you figure out how to factorize it?
No, sir.
And I guess okay, if you didn't figure out one and two, you wouldn't figure out three and four. Hmm. All right. Well, I'll give all this some more time because I'm waiting to see answers. Yeah. So Christian, I sent a picture in the chat, right? From the last question we did. On the sketch the graph, how did I find the roots? Tell me, Christian, how did I find the roots? First things first, Christian, do you know what it means to factorize?
I, I think so.
That's what we're doing the whole time, you know. Like you see how we write one thing in one bracket, multiply by another thing in the other bracket? That's what it means to factorize. It means that you're writing the equation or the expression as a product of two factors. So like that's what we're doing the whole time. So look at the picture I sent in the group chat. In the picture, you see that the original function, it was 3x squared plus 9x plus 6. You see now or no?
Yes, sir.
And after we wrote that as what? Before we started sketch, what did I write it as? I wrote it as open bracket, what? Open bracket. What did it have? What did I rewrite it as? Tell me, Christian. What did I rewrite it as?
So you rewrote it as 3x, open brackets, x plus 1, close brackets, plus 6, open brackets, x plus 1, plus, close brackets.
Right, but that was not the complete answer. That was not the factorized form. What was the factorized? What was the final factorized answer?
X plus 1, x plus 1 brackets, x plus, 3x plus 6.
Right, that is what it means to factorize. Yeah. So what we was doing the whole time, that was called factorization. So you should be able to answer part 2 at least. Now I want you to look under sketch the graph. Under sketch the graph, you see that I have roots in pink. How did I solve the roots? How did I solve the roots, Christian?
So you took away, so you did x plus 1, which was negative 1 plus 1, which is 0, and then you just times that and you go at 0, so.
Right, so that gives us one of my answers. X is equal to -1. Right? How I get my answer?
So you took 3x divided by 3, then x, then 6, well, negative 6 divided by 3, so.
Right.
And then you got the x was -2.
Great. That's the exact same thing you had to do for number 3, And well, in that same question, what did I say the y-intercept was? What did I say the y-intercept was?
So you said the y-intercept was negative, was 6.
Okay, so look at this question. What do you think the y-intercept for this question will be?
2, sir?
Yeah, that's it. Yeah. So you could handle this question, because we covered everything that you need to know to answer this question. So you could handle it technically. Amira, let me see what you have here. The first one is correct, the y-intercept. The factorization, okay, something looking wrong here, Amira. Something looking wrong. Amira, you there?
Yes, sir.
Right, so Amira, if you pull out 5x from 5x squared, it'll be x, right? That part is correct. Now, remember how it is supposed to work, right? The number on the outside is supposed to multiply by the numbers on the inside to give you the original terms. So 5x by x, yes, that's correct. 5x by 1 is what? I see you have 5x by 1. What's 5x by 1? Tell me, Amira, what's 5x by 1? Because I see you have x plus 1, So where's 5x by 1?
5x.
Right, but what are we supposed to get? Look at the line before that. What are we supposed to get?
5x squared.
No. Remember, you're supposed to put on a border, like per line, split it, and your goal is to factorize. And so if you multiply it out, you're supposed to get back what was in the previous line. So in this example, 3x by x, that does give me back 3x squared. 3x by 1, that does give me back 3x. But if you look at what you had,
Okay, so I understand.
you're getting back the 5x squared, but what are you not getting back?
It's 10.
So what are you supposed to put inside that plus 1? Tell me, where you had to put inside that plus 1? What by 5 would give me back 10?
2.
Yeah, that's it. And
So, but how you will get back 5x?
all right, watch this, right? If you write 5x by x plus 2, Look at how it's going to work out, eh? That 5x is going to multiply by x. Where's 5x by x?
5. Oh, okay, okay. All right.
And where's 5x by 2?
10x.
Yeah.
Okay.
And you here they said, what you do there was illegal, you know. You can't factorize 2. I see you pull out 2. If you, in maths, if something looking illegal to do it, you know. But Max, that question, Amira. Does 1 and 2 have anything in common? 1 and 2.
No, sir.
No, you can't factorize that then. Supposed to leave it as it is. Yeah.
Okay.
It's a tricky question I give all. A little tricky, but I'll show you all something just now. But I hope you can see the mistakes you make. All right. Um, Sienna, let me see where you sent. All right, so Rena, we had to work. I mean, Sienna, we had to work on how you're presently working, but you technically weighted is not wrong. It's not wrong, like it's fine, it's correct. It's just we had to work on how you're structuring your working. That's all. But yes, Sienna, that looks correct. One thing though, that's supposed to be -2 and -1/5. I'm not seeing the negative by the 2. Sienna?
Where, sir?
Um, I'm not seeing the negative by the 2 on the graph. Figure the
Oh,
negative
okay,
sign.
sir. I think I forgot to put by the 2.
You're gonna lose a mark for that, you know. I'm telling you.
Okay, I
Yeah, boy. Gotta be careful. All right, Nia, I seeing some errors. I seeing some errors. Okay, so Nia, couple things, right? You factorize it correctly, but the way in which you wrote it was a bit funky. Because Nia, you there?
Yes, sir.
For 5x squared plus 1x, I see you write x is equal to 5x plus 1. I see you write that. And then I see you do that for the other side too. I see you say 2 is equal to 5x plus 1.
I kind of get a little confused. I kind of like confused myself with that one.
Let me think about what this means, eh? No, it's not equal. X would not be equal to this. What we really doing is we actually pulling out what they have in common. So you didn't have to put an equal sign, you just had to put x. You just had to put x. You didn't have to put an equal
Oh,
sign here, you just had to put 2.
oh,
Because
that's it?
that's the mistake you make there because like look, in all my working before, you see I put equal sign there. Check that.
Man, I hallucinated or something.
Yeah, all the working that we did previously, there was no equal sign. So you factorize correctly. You solved the values for the roots slightly incorrectly. Because Nia, if you move across +1, or +1 turn 2.
-1.
Right, so that's a mistake. It's not supposed to be
Oh,
positive 1/5.
oh,
And another thing, right? That graph, you gotta fix that graph. Even if you calculated x wrong, you still needed to know where to place it. And let me explain. So I see you draw this. I'm not calling you out or anything, but it's for your own good. I see you draw that, right? So Nia, let we understand something. Do you know what the 2 stands for?
the y,
The y what?
the y-intercept.
The y-intercept is where the graph is doing what?
Oh,
The graph what? Tell me, the graph. Finish my
when
sentence.
when it like reaches the point.
Where it cuts the y-axis.
Okay, wait. Okay, yeah.
So like,
Alright.
okay, so you see this curve over here. That 2 tells us where the curve, like it tells us where the curve is supposed to be cut on the y-axis now.
Yeah.
But, but you just had the 2 there for style. No, no, the two not supposed to be there for style. Another thing, do you know what the roots are?
What? It's,
The,
I,
the
I
root.
didn't realize I do that, no.
But do you know what the roots are? The roots.
Yeah. Where it cuts the X.
Right. So if you did make a mistake, right, then even if it did make a mistake, the negative 2 is supposed to be over there because it's where the graph cut on the x-axis, and 1/5 is supposed to be here because it's where the graph cut on the x-axis. So you had to work on these things.
Okay.
Sir, I have a question.
Yeah?
Where am I working? I need to fix.
Let me tell you. But let me just check Kelly's. Kelly, you sent me a bunch of pictures. Uh, Kelly, excellent job. That was perfect. The first picture you sent me, that's exactly what I want to see. Good job.
Yeah, I think
Um,
I messed up my graph too.
yeah,
That's
wait,
the
yeah?
last picture. You could look at the last picture because it's everything all together.
No, you didn't mess it up. You didn't mess it up. That's fine. It's correct. Why
Okay,
did you
thank you
think
so
you
much.
messed it up?
Because I was looking, I look up at the screen and then I saw your graph and I was like, something looked kind of off of my graph and your graph.
Oh, that graph I just draw was a sketch. Yeah, that was like a sketch.
Oh, okay.
Yeah, Serena, excellent job. We just had to work on writing that a little neater, right, Serena? But excellent job. Sienna, you had to ask me where it went wrong.
Yeah, am I working? Where I need to fix?
So putting negative by the 2 and the negative by the 1/5. And you didn't make any mistakes really. It's just how you wrote it working. Could have been better.
Okay, so thank you.
No problem. So I see Adrian send me his working. Let me check where you have the Adrian. Adrian, you there?
Yes, sir.
Adrian, what if I told you you factorize that correctly? Yeah. Big up yourself. Big up yourself. He gets it. How you feeling about the factorization part, Adrian?
Feel alright, sir, but the sketching part of no problem.
No
Trying to
worries. No worries. We'll get there and I'll explain it to you properly. So I'm gonna call upon these people. Christian. Christian, I'm looking at you. Christian, we had to understand this thing before we end class today. We have to, right? So Christian, you always stay on standby. Amira, I want you to stay on standby too, because you had to look at how you're writing and working. Nia, I want you to stay on standby too, because again, I need all you to pay attention how you write your working. So Christian, if you are confused by absolutely anything, just tell me no straight up, eh? I don't want you to beat around the bush. You know this is our safe space. It will only get worse if you say you understand and you don't truly understand. So, Christian, read part 1 for me.
The y-intercept value for f of x.
Right, the y-intercept value. Now, the y-intercept value is always the c value. What is the c value from that function? Check it out.
2, sir.
Yep. So, y-intercept value is equal to 2. Adrian, do you know why that is correct? Or not?
no.
All right. Do you know what the okay? Let me just show this something quickly, right? And Christian, I believe you'll benefit from this, as well as everybody else in class. I'm just going to draw a random line over here, right? A random line. This is called the Cartesian plane. This is the y-axis, and this is the x-axis. So, guys, what do you think I'd call this? this point over there. What do you think I'd call that point? So that's where the line cut the what axis. Where did the line, what happened in there? Christian, what happened in there?
Intercept.
Adrian, intercept. Christian, you seen that, right? Intercept. Christian, let me know if you're seeing that. Intercept. It intercepting the y-axis. Cutting the y-axis. Christian, you there?
Yes, sir.
Let's see it now for yourself, right? That's where it intercepting the y-axis. Now, Adrian, in the Cartesian plane, you could move, and what controls your movement is really the x value and the y value. So, Adrian, this point over here, we call that 0, 0, right? That's the origin. Now, say I were to give you a point, which is like 2, 5. You need to understand that the first value is the x value, and the second value is the y value. So if I said 2, 5, that would mean that you're starting from the origin, you're moving 2 spaces to the right, and then you're moving 5 up. That is what it means to plot a point. Adrian, I don't know if you understand that.
Yes, sir.
So like, again, the first value is the x value. So if I say x is 2, that means 2 on the x-axis. And if I say y is 5, that means 5 on the y-axis. And that's the point over here. Now, let me ask that question, Adrian. If this is the y-intercept, what axis is that point on? Where's that point? That point is on which axis?
2.
Say that again?
2.
Wait, let me erase this. This is just a little example. But what axis is this?
The y-axis.
Right. If I want to, remember, you're always starting from the origin, Adrian. So if I want to reach this point over here on the y-axis, would I move on the x-axis or would I just move up?
Move up.
I would just move up, right? I would just move up. So tell me, Adrian, was there a horizontal movement? Did I move left or right?
No.
No. So the x value tells you how you're going to move left or right. But did we move left or right?
No.
No, so our horizontal movement is 0, meaning the x value is 0. But did we move up or down? We move up, right? So that would be a specific y value. So you would have a y value. So Adrian, we say at the y-intercept, the x value is equal to what? What do you think? Think about it.
0.
Like 0. Think about it. The x values, check it out. This is the x-axis, right? The x-axis would take you either left or right. You see in that?
Yeah.
Depending on what the x value is, like, okay, if the x value was 1, I would move 1 space to the right. If it was -1, how do you think I would move?
Close to the left.
Exactly. But if I want to go from the origin to this point over here, is there any horizontal movement?
No.
No. I just going up. That would correspond to a y value. So if that is the case, then my horizontal movement or my x value is 0. That makes sense?
Yes, sir.
And over here, the graph is cutting the what axis? Anybody could
The
answer.
x.
Right. So I'd call this the x-intercept. Anybody could answer this, right? If I'm starting at the origin and I want to go to this point, what movement would I do? What movement would I take? What movement would I take? Vertical or horizontal? So I want to go from here to here. What would I-
Can you repeat that and hear what you say?
Guys, how would I move if I wanted to go from this point to this point? What direction?
Left, sir?
I would move left. Would I move up or down after?
No, sir.
No, because I reach where I want to reach, and that makes sense?
Yeah. Yes, sir.
Adrian, look at this, right? I start in
Yes,
here
sir.
and I'm moving to the left and I reach my destination. Am I going to move up or down?
No.
If I'm not moving up or down, then what do you think my y value is? Remember, the y value corresponds to either up or down. So if I'm not moving up or down, where's my y value, you think?
0.
Exactly, because there's no y value. There's no vertical movement. The vertical movement is 0. So y is 0. Tell me if you understand that.
Yes, sir.
So when I say find the y-intercept, remind me, what is 0 at the y-intercept? So you're on the y-axis. You're only moving up or down. So what was 0? See if you can remember that.
0,
Check it out.
0.
If you're on the y-axis itself,
Yeah.
what is 0? The x value or the y value? Remind me.
Y.
Nah, the y value can't be 0 because think about it. If you're somewhere on the y-axis itself, then that could never be 0. The y value would have some value. The x value would be 0. Because if you're on the y-axis itself, that means you could
Yeah.
only move up or down. If you could only move up or down, what is your horizontal movement? So remember, horizontal just means left or right. If you're going up or down, what is your horizontal movement? Are you moving horizontally at all?
No.
Nah. So if you're not moving horizontally, then your horizontal movement is what?
0.
Exactly. So at the y-intercept, you're somewhere along the y-axis, which means you're only moving up or down. So your horizontal movement, which is your x value, is 0. So at the y-intercept, we know that the x value is 0. That's the truth of it. The x value is equal to 0. So if x is 0, you're going to plug that into the function now. This is the long working of, by the way. So that's going to be 5. Anywhere I see x, I'm just going to replace it with a 0. Plus 11 by 0 plus 2. So tell me, Adrian, what would I end up with if we do the long working?
0.
5 by 0 squared is 0. What's 11 by 0?
0.
What's 0 plus 0?
0.
What's 0 plus 2?
0. 2.
2. So the only thing that remains is 2. So, Adrian, that's the whole concept explained. So again, Adrian, if we're talking about the y-intercept, what is equal to 0? Remind me. If we're talking about the y-intercept, what is always 0?
0.
No, what is always 0? The x value or the y value?
The x value.
The x value, because if I say the y-intercept, it means I'm somewhere on the y-axis. Remember, the y-axis means up or down.
No, yeah.
If you could only move up or down, then your horizontal value is 0. You're not moving left or right. And if at the y-intercept x is 0, anywhere you see x, you're gonna replace it with 0. And it just so happens the only thing you'll remain with is the c value, which is the last value. So that's how we know this trick. Right, Adrian? So anytime you're given a quadratic, the y-intercept is just simply the last value, which is the c value. But you understand why now? I hope. And so let's just summarize that, because you need to know this all the time. At the y-intercept, what is 0? Think about it. The y-intercept, what is 0? So, right, x is 0. And at the x-intercept, what is 0?
Just, repeat.
At the x-intercept, what is the y value? So, Adrian, if I say x-intercept, that means the line or the graph cut in the what axis?
Yes, I do I cut in the x-axis.
Right, the x-axis. So if you're on the x-axis itself, how could you move?
Up or down?
Nah. This is the x-axis. How you could move on the x-axis?
Left or right?
Left or right? You could only move left or right. So that means the y value is what? Remember, the y value is up or down. So I'll make a note of it for you here. Think of x as horizontal and y is vertical. Horizontal just means left or right, and vertical just means up or down. So if we are cutting the x-axis, it means that you are on the x-axis. If you're on the x-axis, it means you could only move left or right. So then the vertical value or the vertical component is what? Tell me, Adrian. If you're on the x-axis itself, what's the y value?
Kind of lost.
It might be a bit hard to see, so watch. Watch this, right, Adrian? If you are on the x-axis itself, if you're on the x-axis, say you're over here. You're on the x-axis. Where's the only direction you could move?
Left.
Left or right? Yeah? If you could only move left or right, then where's your vertical movement?
The Y?
Say that again.
The Y axis?
Wait, I hear that one more time. So if you are on
The
the
Y.
if you're on the x-axis itself, you could only move left or right. You could only move left or right. You understand that? You could only move left or right.
Yes, sir.
Right. Are you moving up or down?
No, left or right?
Just left and right. So what is the vertical movement?
Up and down?
You're not wrong, but if you're on the x-axis itself, can you move up or down?
No.
No. So if you can't move up or down, then the y value is what? Remember, the y value tells you to move up or down. But if you're on the x-axis and you could only move left or right, then the vertical movement is what?
0.
Yes, because you're not moving up or down. So that's
Yeah.
why we say at the x-intercept, y is equal to 0, because you're on the x-axis itself. You can only move left or right. The vertical movement is 0. So guys, please remember this. At the y-intercept, x is 0. At the x-intercept, y is 0. All right. Put this note so smaller. All right, Christian in there. Christian, I'm gonna for there.
Yes, sir.
All right, so Christian, we're on to part 2 now. We want to factorize f of x. So to factorize it, what is my first step? What am I gonna do? Tell me, Christian, how are we gonna factorize f of x? Do you have ideas to how you would proceed? Let me know.
No, sir.
Nah, all right. So we're gonna use the AC method. Why? What is our quadratic here, Christian? What is our quadratic? Could you tell me what's the quadratic we have here in this question?
The A 5x squared plus 11x plus 2, sir.
Right, that's the quadratic we have here. So the quadratic here is 5x squared plus 11x plus 2. That's the quadratic we have. What is the value for A?
5, sir.
Right. If it's not 1, you have to use the AC method. Do you remember how to do the AC method?
Yes, sir.
Right. So tell me what to do next.
So the 5 will multiply by 2,
Right? 5 multiplied by 2. What are you gonna get?
which is 10.
Right? And what am I gonna look for next?
Factors of it, sir.
Right. So what are some factors at 10? What numbers could go into 10?
5 and 6, sir.
Okay, well,
5. Oh,
but
yeah, wait.
we also looking for two numbers that would multiply to give you 10. So think of two numbers that would multiply to give you 10 that are also factors at 10.
So is there any number for that, sir?
Okay, you have to be careful, right? So Christian, we are looking for two numbers that would multiply to give 10, but add to give them a what? See if you remember.
I have to give you 11, sir.
Yes. What two numbers you could think of? I promise it's simpler than it seems. Like real simple. I promise.
Sir, I don't know, sir.
No. I'm not gonna help you, and nobody gonna help you. You could figure this out for yourself. You need to develop this critical thinking. You need to develop thinking skills. What by what is 10?
I know 5 by 2 is 10.
Yeah, 5 by 2 is 10. Okay. But if you add that, are you gonna get 11?
Yeah, you're gonna get 7.
Okay, so how else could you multiply to get 10? It's simpler than you think. It's real simple.
Sir, I don't know, sir.
No, you could guys, and he could figure this out. Guys, hype up Christian now. Hype up Christian. Olio, hype him up. This is not some good hype boy.
Yeah, but
Everybody
you can
wants
figure
to
it out way.
Come on, Christian, you can do this.
It's right in front of your face. Well, the both numbers.
Okay, Christian, maybe we could look at 11. What are some numbers you could think of to get 11?
Sir, 5 plus 6, sir.
Okay, 5 plus 6. But would 5 by 6 give you back 10?
No, sir.
Nah. When you see this, you're gonna be like, wait, no.
Not real.
Christian, what are some other numbers I could add to get 11?
Sir, 7 and 5?
Okay, 7 and 5 wouldn't.
No,
Nah.
7 and 4, sir.
Wait, 7 by 4.
7 by 4 is
No,
28, sir, 28.
can't use that. So we can't use 7 and 4. We can't use 5 and 6. Keep going. What two numbers could add to give you 11?
8 and 3, sir?
But would 8 and 3 multiply to give you 10?
No, sir.
Keep going.
Wait, 10 plus 1.
Yeah.
10th wait. Oh,
Yes.
no way, bro.
Yeah. Yeah, I tell you it was real
Yeah.
simple. I tell you
Sir,
it was real.
I was overthinking it, sir.
Yes, it's 10 plus 1 and 10 by 1. Yeah. You see, imagine if I had to take that opportunity away from you to figure it out for yourself. That'd have been very sad. Okay, what next?
So then you and you put back five. No, yeah, 5x squared plus. Oh, wait.
You figure this out. Look at the previous examples. Look at the previous examples and you will figure it out.
Yeah, so now we're doing five. 2 plus, no, plus 10x
Say that again.
plus 10x.
You want to put plus 10x?
Yes, so plus 10x. Then the border.
Yeah, you're forgetting something. Forgetting something. So, like, the whole point of this is that we splitting up the middle term into an equivalent sum of two other terms. So, like, look at our previous example, right? Instead of writing 9x, what did we write?
We wrote 3x.
3x?
3x plus 6x.
Right. And where we get the 3 and the 6 from?
From the 9 to.
Okay. Right. So look at this.
Five x.
No. The whole point of this, right, is that you are not changing anything, you're just writing it in a different form. So, like, instead of writing 11x, what would be the same thing as 11x? What would be the exact same thing as 11x? And this is your hint. This is your big hint.
10x.
No, 10x is not 11x. What would I need to add to 10x to get 11x? And your answer right in front of you. I promise. Right there.
1 to 1x.
Yes, 10x plus 1x. So after you figure out what two numbers to use, you're going to take those numbers and you're going to use it to split the middle term. So 11x is really just
Oh,
11x is really just 10x's plus another x. Right? And what am I going to write next?
you write the plus 2 back.
Right. Now I'm going to put on the border over here. Gonna pull out Trump. Okay. All right, what next? Tell me, Christian.
Then you see what they have in common, sir.
Right. So 5x squared and 10x, what do they have in common?
So,
They have an x in common for sure. Could pull out an x. What else they have in common?
so they have 5 in common too, so because 5 by 2 is 10, sir.
Excellent. So I could pull out a 5. Right. So what I want you to figure out now, what numbers could I put on the inside whose product is going to give you back the original terms? It sounds like I said a lot, but it's not. 5x by what would give me back 5x squared?
5x by 1, sir.
Now, 5x by 1 is 5x. I want to get the squared. X squared, how am I going to get back the x squared?
5x, no, x squared in the brackets, sir.
Okay, when I multiply this term by this term, I had to get back x squared. I had to get back x squared. Right now I have 5x. What by x would give me back x squared? Think about it. Here what we could do, right? We could look at it in a different light. Do you know what x squared means?
Yes, sir. 5 by x.
Right? And we have plus 10 by x. So both of them have 5 in common, right? Because 10 could be expressed as 5 by 2. They have 5 in
Yes,
common.
sir.
I'll pull out the 5. And you pull out the x as well. So we pull out 5x. Right? 10 is the same thing as 5 by 2. So you pull out the 2, by the x. Let's see this. Right? So you pull out 5x. Cool. So what should I write inside the brackets? So 5x by what? It's going to give me back 5x squared. Look at this and I'm going to help you.
5x by x, sir?
Yeah, because where's x by x?
X by x is x squared.
Right? So we get back the 5x squared. And 5x by what would give me 10x?
5x by 2.
Yep. And you see now here too, right? The 2 remains.
Yes, sir.
Cool. Now, this is the tricky part. No. And then over here we have plus 1x plus 2. There are multiple ways you could do this. But watch this. If I pull out 1, tell me, Christian, 1 by what would give me back 1x? I would say 1 by what to give me back 1x? 1 by what?
1 by x, sir?
Right? And 1 by what would give me back 2?
1 by 2.
Yeah. So when you look at this now, are you seeing anything in common between this and this?
Yes, sir. The x plus 2.
Right. So here's a hint for this, right? Anytime you're doing this factorization correctly, you're supposed to get the same thing in these two brackets. Did you all notice that with all the prior examples? If you did
Yes,
this
sir.
correctly, you would have ended up with the same thing in both brackets. And that was kind of a hint. Watch. You end up with x plus 1, x plus 1. Over here, you end up with 2x plus 3, 2x plus 3. So that's a huge hint. It's a huge hint. So that's going to be x plus 2. And Christian, if I pull out x plus 2, what am I going to write?
Five x plus 1, sir.
Yep, 5x plus 1. And that's it. That is what it means to factorize. It means that you're writing your expression or your equation as a product of factors. That's what factorize means. So x plus 2 by 5x plus 1. Is everybody okay with this? People in class, if you got through with this, let me know.
Yes, sir.
Yes, sir.
Okay, cool. By the way, guys, I'm just wrapping up with the Form 4s, right? Form 5 people, we could start just now. We're doing the entire basis today. Entire basis. And we'll take a vote on the next topic. If I finish basis, we could start the next topic one time. Okay, cool. Hence, solve f of x is equal to 0. So, Christian, in part 3, what are they telling us f of x is equal to?
Plus 0, sir.
Right. Now, guys, let's try to understand this a bit further. F of x is really the same thing as what? Could somebody remind me? F of x is the same thing as what? What is f of...
Y.
Right. So this is really saying y is equal to 0. So truth be told, they really want us to figure out the what over here. Adrian, tell me, what do they really want us to figure out? What do you call something when... We call that when y is equal to 0. The what? The what? When y is equal to 0, what do you call that?
Intercept.
The which intercept?
Intercept.
Perfect. X-intercept. And another word for x-intercept is roots. So guys, anytime you see a question like this, where they say f of x is equal to 0, they really want you to go ahead and find the x-intercept or the roots. They mean the same thing. So Christian, what is f of x, Christian? What do we know f of x is equal to?
1, sir.
Now, f of x is not 1. What was f of x equal to?
I mean 0, sir, yeah.
You're not wrong, but I want you to think, look at the bigger picture. What is f of x? Look at the question. And notice they use the word hence. They said to use the word hence. So most likely they want you to use what you just did. So in the last question, we factorized what? What did we factorize, Christian? We factorized what? Look at the question itself. What do we factorize?
You factorize f of x.
Right. So what is f of x equal to? Forget what is 0. What is f of x equal to? What do we know f of x is equal to?
X plus 2, 5, 5x plus 1, sir.
And now they are telling us that that entire thing is equal to what?
To 0.
Right. Do you know how to solve this?
I know to solve the x plus 2, sir, but I don't.
That's okay. We'll figure it out. So to solve this, we're going to put both of the factors equal to 0. So x plus 2 is equal to 0. And we're going to say 5x plus 1 is equal to 0. Now we could get your answer one time. What's the answer, I think, Christian? What do you think the answer is?
Negative 2, sir.
Right, because I would make that bracket 0. Now, to work this out, you need to make x the subject of the formula. So what term here is not the x term? Which one is not the x term here on the left-hand side? What is not the x term?
The 5, sir.
No, that 5 is part of the x.
I mean,
Think about it.
the 1, sir.
Think about it, Christian. Doesn't this mean that I have 5 x's on the left-hand side?
Yes, sir.
Yeah, so that's part of the x term. The 1 shouldn't be there. I'm going to take the 1 and I'm going to move it across. If I move across 1, it's going to turn to what?
Negative 1, sir.
Yes, negative 1. Now to find for x, I'm going to do what on both sides?
Divide by 5, sir.
Yes, I'm going to divide by 5 on both sides. So my final answer is what?
Is x equals to minus 1 over 5?
Yeah, that's it. Okay, is everybody in the Form 4 class? Are they understand this perfectly? And I presume the Form 5s, you should understand this. It shouldn't be hard. People in the Form 4 class, are they understand the parts where they say hence solve f of x is equal to 0?
Yes, sir.
Yes, sir.
Okay, good. Adrian, do you understand that f of x, from the start, it was 5x squared plus 11x plus 2? But when we factorized it, it became x plus 2 by 5x plus 1. So this is really f of x. And they said to use the word hence. So most likely, they want us to use what we just found. So Adrian, if they're telling us f of x is equal to 0, and we know that this is f of x, we will just simply put it equal to 0 and we'll solve. Adrian, let me know if you're confused by anything.
No, sir.
All right, and Adrian, we just solved for the what. This is where the graph is cutting the what axis.
The x-axis.
Perfect, perfect. So I don't think you should have a problem with the sketch. I don't think you should have a problem. So let me do the sketch quickly. So guys, look at the quadratic. Tell me, is this shape wrong or correct? That shape over there, correct or wrong?
It's wrong, sir.
Somebody tell me why it's wrong. Why that wrong? Why is that rubbish?
Because the coefficient is not less than 0.
Exactly, exactly. Christian, Adrian, guys, what is the value for A in this quadratic?
5, sir.
X squared.
Yeah, no, not x squared. Adrian, what is the value in front of x squared? 5. So we'll say that as the coefficient. The coefficient is the number in front of the variable. So 5.
Okay.
Is that a positive number or a negative number?
Positive.
5. You think 5 is a positive number or a negative number? Say that again.
Positive.
Positive, right? If you positive, you just be smiling or you just be have a frown face. What do you think? If you're happy, be smiling. So a smile would look like this. This is what a smile would look like. Boy, you have a real big smile, boy. Wow. But hey, any of you ever watch Rick and Morty? Are you know about Rick and Morty by chance? I take it that was a
Yes,
no.
yes,
That looking like
Right.
me seek. That's how you see his name. That is that how you say it? Let me show you what I'm talking about.
Yeah.
Mr. Meeseek. It looks like him. Wait, eh? Anybody that watched Rick and Morty will get what I'm talking about. Are you seeing any resemblance?
yes.
Yeah, boy. I'll leave that over there. Yeah. Adrian, this is you. Grandpa Arrow saying this is Adrian. All right, cool. So, Adrian, we understand that my graph is going to look like this for sure. It's going to look like that. But we need to figure out where we're going to place it. And Nia, I'm looking at you now, Nia. Nia, you there?
Yeah.
Okay, so Nia, when you look at the values for where the graph is cutting the x-axis, where's the graph cutting the x-axis? Tell me, where is the graph cutting the x-axis?
By the positive.
By the positive. Let me look at the roots, right? What were the roots?
-2 and -1/5.
So, do you think that okay, by the way, this is the x-axis, right, guys? That's the x-axis. So, Nia, if I draw my graph here, where is it cutting the x-axis? At positive values or negative values?
Positive.
That can work, right? Because my roots are what? What are my roots?
Negatives.
Okay, what about this? Would this work?
No,
Explain why it wouldn't work.
because one side is on the negatives and the next side is on the positive.
Yeah, bipolar. Can't have that.
Yeah,
What about this?
yeah, that would work.
Adrian, you agree with that? Or no? Be honest with me, Adrian. If you're confused, just talk to me. Simple as that.
Agree, sir.
Um, say that again.
Agree.
You good?
Yes, sir.
So, like Adrian, you're seeing for yourself that the x values are negative, right? They're negative, negative. So, which one is smaller, -2 or -1/5?
1/5.
-1/5
Oh,
is
oh,
bigger.
-2. Yeah.
So negative
-2.
-2 is going to come over here, and -1/5 is going to come over here. And Nia, what is going to come over here? Tell me, Nia. I want you to look at your quadratic. Wait, Nia and Christian, I want all you to answer this question. What do you all think I should label over here? What do you all think I should label over here?
2, sir.
Both of you agree with the 2?
Yes, sir.
sir.
Bet 2 is the correct answer. So after today's class, you should be able to factorize any quadratic. You should be able to solve the quadratic when it's equal to 0. So you should be able to figure out the x-intercepts. That's what I just said. You should be able to figure out the y-intercept and sketch it. So after today, you should be able to answer most quadratic questions in the CXC exam. You should. You should. So guys, take a screenshot of this. I'm going to give you all a question for homework now. And yeah, please do the homework. Please, for your own good. I'll make some good progress today. I would hate to see like the progress just dissipate. We don't want that. You know? We don't want that. Right. All right, let me give you that question now. I'm going to give you a similar. Actually, I'm looking for a past paper question. Form 5 people, give me a year to get the Form 4s. Form 5 people, what year I should give the Form 4s to do?
2023.
2023, bet.
2019, sir.
It sound like only want two sets of homework. That makes sense. January 2023 or June 2023? Which one?
June, sir.
So you're about to call on next paper, the math with homework.
Wait, Oh, 6 marks? Nah, boy. That's too easy, boy. What? What? I'm giving you 6 marks now. So this is cake. Well, I had to get this correct, right? Guys, we would have done functions already. So you should be able to handle this. You should be able to handle this. Until you remember how to do functions. Yes or no? Guys, yeah, functions. I mean, a quadratic is a function, you know. A quadratic is a function. Did functions the other day, so I think I should be able to handle that. I think. And if you're having trouble, well, it'll just like contact each other. I'm sure like you'd have somebody in class that know everything. Well, most of everything. And they can help each other. Okay, and 2019. 2019. Let me go. 2019. 2019. Let me go May, June. Is this paper 3? Yeah, it's a paper 3. But this is a good question. Yeah, it's an excellent question. Yeah, I love this question actually. It's a great question for you all at this level. So I given only a good amount of homework. Well, I wouldn't really say it's a good amount. It's just I really wouldn't even say it hard. I believe y'all could do this. I believe y'all could do this. The question is, do you think you could do it? That's the question. Let me hear, guys. Do you think you could do it?
Yes, sir.
That's good. Give me one more year quickly. One more year. One more year.
Yes, sir.
2010, sir.
2010. Bombo clat. Look, we have a Jamaican in class now, Adrian. And Regina. Adrian and Regina. Are they say bombo clat plenty? Or like no? I find I say it, you know. Grandma at times. Adrian, you say it plenty?
Yes, sir.
Okay. Um, Lovely. It's a good question. If it's up to me, I would say every question is a good question. Let me stay quiet. So I give you a little homework, all those stick. Those stick. Those stick. You learn a lot today. I would hate to see you just forget it. Now the questions that are going to be asked will be slightly different, so you have to try and think now and understand what they're asking. But you should be able, you have most of the knowledge you need to know, right? You have most of the knowledge. We did functions previously, and now we're doing quadratics, so it shouldn't be, you have to use way learning functions first, because this is our function. So this is your homework. Let me send it on the chat. Yeah. Adrian, you okay?
Yes, sir.
All right. Christian, you good?
Yes, sir.
Nia, you good?
Yes, sir.
Okay. You understand the significance of the x-intercepts and the y-intercepts now on the graph?
Yes, sir.
It's not there for style, right? Not there for style.
Oh, no.
Yeah. That's kind of bad, but it's not there for style. You gotta use it. All right. So guys, that's it for the Form 4 class. Y'all could leave. I'll send the notes in the chat. Later, guys. Take care.
Bye,
Form
sir.
5. Form 5 to
Bye,
do
sir.
already,
You
you
too.
say? Wait, Christian, you saying you going? And you have Form 5 to do?
Yes, sir.
You say he's going to leave. I want to know what you're talking about. You have master grind again. Mhm.
So we only do non-based topic today, or we gonna explore some other
We will see.
topic?
We will see how everybody is faring with bases.
All right, so
You
that's
know,
a new thing to bring.
it was always in the syllabus in number systems, but now they're focusing on it. I'm
All
seeing.
right, okay. Okay.
You check the 2026 paper by chance?
Yeah, I did.
Yeah, it was in the 2026 paper.
I just
So,
browsed through it. Pay attention.